Hey everyone, and welcome to today's webinar. Thanks for taking some time to join. Before we get started here, we'll give everyone a couple minutes to cycle in, but in the meantime, just a couple quick updates from the SE side. Wanted to share screen really quick here. You can see on our website, the Zenmuse L1 page. We've recently added the Zenmuse L1 operation guidebook. So if you're looking to learn a bit more about the solution, you have customers currently flying this platform. This guidebook here is a wealth of knowledge. So a big thank you to both Run and Kyle on our SE team who put a lot of work into this. You can see examples regarding proper data collection, camera calibration, settings, different use cases, post-processing, a lot of good information there. So if you haven't had a chance to review that or share that with customers who are using the L1, I would certainly encourage you to do so. And we'll make sure to share a link to that if you need it at the end, but that's on the L1 page there. Alrighty, figure we can get things going now. My name is Grant Hostka. If we haven't met before, see a lot of familiar faces on the attendee side, so thanks for taking some time to stop in. I know we originally were planning to have Garret Bryl on today's webinar. Unfortunately, he had something come up at work, so wasn't able to join us. I know as much as he loves helping out public safety and testing on the drone side, fortunately is not his full-time job. He did go ahead and make a short video for us, so we'll share that during the training today for you all. And Garret sends on his greetings and apologies for not being able to make it directly to the webinar itself. Alrighty, so hopping into things here, we'll cover H20N, has some specs and key information. Hopefully that'll be review for you all. Share testing notes and video from Garret and the PSURT team, some test data, reviewing the software features, and then some key items for demoing the product. And then the second part of today's training is based on request and feedback from some of you who are looking for some general use case training. So those who perhaps a bit newer to the DJI enterprise product line and some of the different use cases within the industry. So we'll be able to go through some of our main industries and use cases and what drone or solution may be the best option there. And then we'll finish off with Q&A and share links. The webinar itself is being recorded and will be sent out to you all a few hours after the conclusion and processing. So feel free to add any questions throughout in the tab on the webinar, and we'll go ahead and get started here. So H20N, obviously a screen here probably looks a bit familiar from the website, but key idea here is H20N is built for 24/7 operations. So still has those strong capabilities during the daytime, but improves operational performance at night. Looking at kind of our key flagship items here that you see on the website as well. Starlight night vision, 2 thermal cameras, 20x hybrid optical zoom, laser rangefinder, syncing split screen, our night scene, IP44 rating, and then an operating temperature there as well. 5 sensors here, and I know I've seen a bit of confusion here, so I want to make sure to review this with you all. We have 2 different thermal cameras here, one at a bit wider focal length, and then the tele thermal camera. Then the bottom right there of the camera looking at it is the tele thermal camera that has the longer focal length. Both 640 by 512, you can see the equivalent focal lengths there as well. And then both the wide and the zoom camera are Starlight sensors, which we'll cover here in just a short second, but you can see wide's up in the middle, and then the zoom camera on the bottom left there, and then finally the laser rangefinder on the top right side there as well, with about a 3/4 mile range. So when we get into a Starlight sensor, how you measure light is actually in lux. So the name Starlight, as we get past full moon, half moon, to the light of stars is really what enables this sensor's name and the capabilities. We have a much larger pixel size for the camera itself, allowing us to see more light. So you can see an easy comparison here on the bottom right, just the regular non-Starlight sensor zoom camera, and on the right, the Starlight camera view. So a couple things going here, obviously the much bigger pixel size, and then the second one being some of the software algorithms that are going. The team's been putting a lot of work in on those. Essentially, it's very difficult to reduce noise, and that's what the software side helps out with. Motion detection algorithm, advanced neural network noise reduction, and then an auto-focusing algorithm as well helps to give you a brighter, clearer picture. So exact same lighting in both of these images, and you see how the Starlight sensor can provide a lot more information. So when we kind of compare specs across the board here, obviously, one of the first things you may notice is that the visual camera does have the lower megapixel count compared to the H20T, but that's due to the pixels being so much larger. Same thermal camera across the board. We have 2 thermal cameras for H20N. Same laser rangefinder range, IP rating 45 for the drone, 44 for the payload. And then obviously we get into other specifics, more aircraft in regards to payload capacity and the FlightHub 2 compatibility. So overall, H20N optimized for night, but still has the capabilities to give strong performance during the daytime as well. So if we just line up all the features here, this gets us into one other key point on the H20N that we've gotten a lot of questions about, is you see that H20N does not have the AI spot check feature, which allows you to fly an automated waypoint mission, mark specific items by annotating it, and then the object detection algorithm will look for that when the drone repeats the waypoint mission, and that's not present with the H20N. And that's because overall, the visual camera is going to be better for inspection scenarios with the H20T. And then secondly, when we're looking at the H20N, we don't recommend that for very accurate thermal measurements that you probably are going to need when you're looking at something like a power line inspection. When we're going from one thermal camera to another, when we have such a long standoff distance, we have a significant decrease in accuracy. So even though it does have that longer focal length and you can get a good thermal picture at the further distance, it's not necessarily recommended to use that and make measurements from it on the power line scenario side, because we're looking to keep those within a tight, accurate envelope if we're going to make a decision about a specific component. So we want to stay with the H20T on the inspection side when you're making quantitative measurements. On the flip side, what the H20N has that the H20T does not is a split view zoom. So we'll show that in one of the videos here, but essentially you can tie the visual and thermal cameras together. So as you zoom one in, the other zooms as well. Obviously the thermal zoom only goes up to 32 times, but a nice feature there. We don't have to zoom both at the same time. So new software capability there. At this point, before we get into some of the test data from our side, I want to kick it over to a video from Garret for you all, where he did some testing with the PSURT team. So I'll swap my sharing over to that for you all.
Hey, it's Garret Bryl. I'm out here with Jack White and Don Casey. We're doing some little testing with the M30 and more in particular the H20N. One of the questions we had was, what does the H20N bring to the table? So we wanted to start doing some testing. First, let me say we put these, both of them are in night scene mode, and then it's side by side so you can kind of see the thermal and everything else. Now, one of the first things that we noticed is that with the this is with the M30. Again, this is night scene mode. You can't make out a license plate. This is kind of zoomed in. We're up there a little bit of 100 feet. This is the scene that we're in. We have just a slight city glow the background. We're in the woods. We're just on the kind of the outskirts of the city. So we're in darkness. And with this one, you cannot make out the license plate. With the H20N, you can make out the license plate very clearly. One of the things we want to test is the ability to see a weapon. We have an individual out he's just out in the parking lot, kind of out in the open. This is on the M30. This is in night scene mode. This is the thermal. You can see him. Difficult to see a firearm. If he showed it, you could possibly see it, but in this case, kind of difficult. In the night scene mode on this, you can't see it at all. It's a black parking lot. This is the M300 with the H20N, and look, you can see. Look at the. There's a AR-15 in his hand, and this is in the thermal. Kind of difficult to see. It's about the same as the body temperature. See, as he turns around here, it should be able to see it. And look over here. You can see it. Now he put it behind him. He'll show it in just a minute. There it is. Look at it right behind him. You see it? Over here it's difficult to see. Here you can see. Fire on. Hopefully they bring it around. Gonna come over here again. This is what we see. Oh, there he goes. There we go. Now we can actually see it in his hands. And see it clearly. All right. So that was a good test. I know this has been a question for some on whether or not you'd be able to see a IR laser off of. This is off of a SWAT rifle. You probably can't see that, but that's the IR laser. Go ahead and move it. There you go. Over. If you can see it right there by the X. So that is the laser off of the rifle. I'll go ahead and try to show you. That's the building over there, and you can see it. It's not visible to the eye, but the H20N is able to see IR laser. Of course, the one you see on the X, that's the one coming off the H20N. This is the one, the round one is the one off the rifle. So one of the things we wanted to test with the H20N is the IR strobe. So we have an officer out here in gear, and he has an IR strobe on his head or on his hand. I don't know, but you're able to see not only the IR strobe, but you're actually able to see the officer himself. I don't know how well you can see it in this video, but it's very light. You can see the officer himself and the surrounding details. So here is the M30. So you can see, you'd have to do side by side. You can see thermal. You can see over here the strobe. You can't see strobe here, so you're kind of looking at relevant to the X, but you can't really see any details again. You see that there's the officer. You can see a strobe, but you can't really see it all together. Here, this is with the M300, the H20N, and you're able to see both the thermal signature and over here, even more clearly the strobe, and the officer himself, and all the surrounding stuff. There's trees, and there's like a little brush line. There's where they mowed the grass, where you can see all the details of where he's at, and the situational awareness is definitely much higher on the H20N. I know a lot of people are interested in the IR strobe capability, so I'm going to be able to capture that. All right, had to capture one more thing. This is actually pretty huge, okay? So right now we are up at 357 feet in the air, and we are, where's our distance?
Very bottom. So 1,817 feet out.
Okay, 1,800 feet out. Okay, again, this is thermal. This is the H20N. All right, zoomed in a little bit, but that's that IR strobe from that far away. I'm going to try to show you the M300, see if I can get it. If you can make that out, way the heck out there. All right, and where we're looking is back against these woods over here. And again, you're able to see that IR strobe.
Cool. Big thank you to both Don, Garrett, PSURT crew for putting that together. Summarizing some key use cases they covered there. The first one that they appreciated was information side. So obviously you could see the ability to read the license plate at night in the dark, and they were struggling to do that with M30 or H20T, even using a night scene mode. And I think right now is probably a good opportunity to review that night scene mode as well. On the camera itself, you have the capability to turn on night scene mode for H20N, for H20T, and for M30T. And when we're looking at night scene mode, essentially that is a name for the IR cut feature. So these visual zoom cameras have a IR cut that you can essentially let more light in, kind of like a security camera that you might see like in a parking garage. So you do see that the feed turns into black and white when you do so, because you're letting in a more wider band of light there, but you're able to see more key details. So obviously night scene is a feature that is turned on automatically with the new M30, and you can kind of change that in the settings. But overall, that's why you're kind of seeing the black and white picture there. And we did want to make sure that they compared that kind of against what, the best that the M30T and H20T had to offer at night there. So good information overall there on the license plate side. Second one, we're going to talk about a parking lot with the thermal loading side. So overall, we do have limitations when using that IR camera. If our background is emitting the same amount of heat as maybe the person or an object that they're holding, the obviously one here is like a parking lot that's obviously going to gather a lot of heat during the day, and kind of in that transitionary period during night is certainly going to be emitting that as it cools as well. So it can be very difficult to identify people at points with the IR camera or what they may be holding or doing. So the ability to see a firearm, as they showed, is another important one when we move into kind of the officer safety side. And then finally, IFF, so identifying friend or foe, if you're not familiar with that term. But we show the ability to see both the IR strobe as well as the people and surroundings. Obviously, you do need to have the night scene feature enabled to identify these IR strobes, because we need to allow that band to be viewed by the camera. But you could see on the M30T side that you're really relying solely on that thermal camera for information on the surroundings, while with the H20N, you have the expanded capability to see it visually with the H20N camera. You don't necessarily need to rely on heat difference there. So think about SWAT missions, SWAT teams. I know a lot of folks do end up deploying those IR beacons to identify team members. So that's a nice benefit of the H20N as well. And since we're on the topic, a common question as well in regards to those IR beacons, that isn't something that you actually see with the thermal or what we call IR camera as well. That's seen by the zoom camera using the IR cut, or what's called the night scene feature on the camera. That's what's able to see that band of light and those IR beacons, and is available on the M30 series and any of the H20 series camera by using the zoom camera and night scene. So just a few more examples here. Another obvious example of the thermal capabilities, when we're going from 2 times to 8 times, when you get to 8 times, that's when it jumps over to that second thermal camera. So you can certainly see at the distance here that you're able to see a lot clearer. Another zoom camera comparison, so about 400 feet altitude at about 650 feet away. You can see obviously more details on the H20N of the scene, versus using the M30T or H20T. Kind of another example here covering the license plate itself. So similar to Garrett's conclusion as well by the Starlight, you're able to see this in something we'll talk about a little later on, but it's good to get a camera angle where you're a bit more over the object that you're looking at than trying to zoom completely, horizontally in on something. A few examples here. You can see H20N, M30T, and H20T. So obvious benefit here, seeing the details of the people, extremities, zooming in with that thermal camera. So same settings, same distance for all cameras. As we know, there's just limitations to the digital thermal zoom compared to switching over to a second camera there. So there is H20N in action. And then daytime as well, right? We still need capabilities as well for the sensor during the daylight hours. H20N obviously isn't quite up to snuff with the H20T. It still does have some performance gains during the daytime, but overall, the H20N still provides a good picture at a further distance with up to that 128 times zoom. And then just quickly on the intelligent features, I know many of you are very familiar with these, but with the H20N, you still do have the capability to use the high-res grid. So on this side, essentially draw a box. You can dial in the zoom to whatever level you'd like and define those grid cells, and the zoom camera will take a photo in each section. And then the second one being the synchronized split screen zoom. So you can see that we're able to zoom with both cameras at the same time there. And we'll just be using the zoom function on the RC. With the M300, remember you can hold the function button on the top right of the controller and use the dial to do granular zoom, or touch on the Smart Controller Enterprise interface itself. Keynotes here on the UI. Right here above the photo button is where you're going to switch your photo mode if you want to do high-res grid, panorama, any of those items. By tapping and holding in the middle here on the zoom function, that's where you can bind the two cameras together, the zoom and IR, like Garrett showed on his video. And then finally, if you wanted to turn off night scene, to just see the difference there, or maybe there's a situation at night where you need to see the color and you don't want to use that, you can go into the settings here in the top right. You're going to make sure you're in the zoom camera view. Currently you can see it's in wide here, but you go into zoom camera view, go to the settings, go to the wrench, and then you can turn night scene between auto, off, and on. And in that view, you can also turn the laser rangefinder completely off. As in, you could see in the video from Garret and some of the other ones, you will see the laser rangefinder in that night scene mode unless you turn it off. So it may be useful for you, or you may want to have it off. So just key notes there in regards to settings and where you'd find them. Obviously, some of the other features with the camera as well, we have the smart track capability, and then we have the ability to drop the pins using the laser rangefinder from the camera as well. We can have the camera look back at the pin on the pin side, and on the smart track side, obviously the gimbal and drone will move left and right, but it's not going to fly after it. So overall, same software features that you know with the H20T overall, minus the high-res grid. On the thermal side, you do have isotherms, color palettes, temperature alarm, gain modes, and can take radiometric JPEG imagery. Circling back on those real quick, on the IR side, you're going to hit the temperature bar up here if you want to adjust isotherms or your color palette. Your gain mode right here switches between high gain and low gain. So if you want to see the wider temperature range for something like a fire, you'd obviously want to make sure you're in the low gain mode for the wider temperature range. SBS stands for side by side, FFC, flat field correction. And then one of the other ones was the temperature area measurement, or spot. You can see right there, spot temperature. It's a simple tap on the screen for the spot temperature measurement, and it's a tap and drag from the top left to the bottom right, then release the finger to get the temperature area box where you'd see the hottest and coldest temperature and could set a temperature alarm. So something I've seen folks like to do on the search and rescue side, they'll set up that temperature alarm just as kind of an additional tool in the toolbox for them to stop and maybe investigate further in regards to something they may have missed just visually looking at the screen. Radiometric JPEGs can be looked at in the thermal analysis tool, but remember on that side, we're looking for a more general difference than a highly accurate measurement that I would recommend on the power line scenario side. Is compatible with FlightHub 2 as well, so you can go ahead on the flight route side from the main menu, create a mapping mission, select the H20N payload, wide or IR. You can turn on the cloud reconstruction and do that in visible or IR. Two options there. In the settings, you can change overlap, but it makes you stay within certain minimums. And then you'll see both on the FlightHub 2 side and the controller side, you'll have the live 2D map updating as the drone is going. And then obviously the capabilities to live stream to FlightHub 2 as well. If you're not familiar with FlightHub 2 or have some additional questions on how to get that set up and running, we would refer you to last month's training where we went further in depth there. Just shoot me an email if you need a link to that, or if you have any questions or feedback, please do send that on. Just both with the H20N and with the FlightHub 2, we appreciate those of you who have taken some time to share feedback from yourselves and from end users to help us improve those products. So finally on the H20N, when we're actually going out and demonstrating the solution, a few suggestions to optimize performance of the sensor. Empty spaces where we're able to have a bit more natural light is useful, and then also from the safety side can be beneficial as well. When we're looking with the H20N camera, avoiding very bright lights that might wash out the sensor can be advantageous. So just moving the camera a little left, a little right. Remember, you can always double tap on the screen if you want the camera to focus on a specific area. Clear night, when we can take advantage of the stars and their star light, the half moon, full moon, etc. is useful. If it's completely cloudy and we're in the middle of nowhere with no ambient light and no natural light, sensor is going to struggle in that type of scenario. Obviously, most times you do have some light you're working with. And then obviously always just remembering to apply for proper flight permissions, stay away from strong magnetic environments, and then trying to scout ahead of time if possible. So I think that's even realistic for regular operations as well. Obviously you see SWAT teams scouting beforehand, so thinking about UAS operations beforehand as well, and any obstacles in the area as well will certainly lead to a successful deployment. And then a few other items as well. We kind of talked about avoiding focusing on the brightest part of the subject, the ability to essentially turn off the laser rangefinder in the camera settings while we're in the zoom camera view. Another note here is you can pre-program one of your custom buttons to turn the night scene on and off, but you'll need to be in the zoom camera to use that function. Shooting from the top of the target, not exactly nadir, but closer to that 90-degree down angle can lead to a better visual representation as well. And then making sure to kind of utilize the thermal camera at a longer range so you can really see significant benefits of going to that second thermal camera. Another thing at night as well is using the CSM radar. If that's something you have access to or are able to demo, obviously that is a very useful tool where we have 360 degrees around the drone itself and works during the day and night. So kind of a nice item to demo alongside. So that concludes things on the H20N side.